Okay, everyone, we're going to start differentiation, and we've got 3 lessons this week. The first one is Introduction to Differentiation. So I'm going to talk you through my notes. So if you access my notes and you just they're up online for you, if you copy them out. So I just want to talk you through it. So what is differentiation? Differentiation is the process of finding a gradient on a curve at any point. The gradient on a curve constantly changes. Now, I want to think of this for a second or two. If you look at this curve here, on this side of it, the curve is going down, so the gradient is going down. Then it stops, and then the gradient starts to go up. So you can see on the curve here, it's going to be a negative gradient, whereas over here, it's a positive gradient. So the gradient always changes on a curve. On a straight line, if you've got a straight line, the gradient never changes. And that's where the difference of y's over difference in x's comes in. But on a curve, it constantly changes, so that's important. The way you write the gradient or differentiation is dy by dx or f dash x. The gradient function or derivative, that all describes differentiation and gives a gradient in terms of x. You'll see what that means later on. It's quite straightforward. Now, calculus is a branch of maths derived by Isaac Newton. The reverse of differentiation is integration, and this is also a branch of calculus that we'll be going on to later on, but we'll do this one first. So that's what differentiation is. So it's the gradient of a curve, and it can be written as dy by dx, f dash x, gradient function or derivative. So let's have a look at these curves. So we've talked about this first one. This side has got a negative gradient, then it goes stops, so it's got a flat gradient there. Horizontal gradient. The bottom is called a turning point or a stationary point. It's got a gradient of 0. It's completely flat, no steepness there. This is called the minimum turning point because the graph comes down to a minimum, then it turns and goes back up. And this side of the graph has got a positive gradient. If we look at it, it's the other way around. This side of the graph, you're climbing, so it's a positive gradient. Stops, so the gradient here is 0. That's at the maximum turning point because it goes up to a maximum, stops, and then turns. And that's a negative gradient. Now, the rules of differentiation. There's a little bit strange when you see it written out like this, but when you see it through examples, it's quite straightforward. If you've got y equals any number x to the power, when you're differentiating, so you write dy by dx, you bring the power to the front, so it becomes an x, and you take 1 away. So you'll hear me saying power goes to front and take 1 away. If you have a x on its own without a power, the x disappears. And the reason for that is over here. So a number x to the 1, you bring your power to the front, then you take 1 off. 1 minus 1 is 0, anything to the power of 0 is 1. So it just becomes a times 1 or just a. So power to the front and take 1 away. X disappears. Now, if you have a number, A is just standing for a number on its own, and you differentiate it, it goes to 0. And that's because y equals A is the same as if it was x to the 0 beside it. X to the 0 is a 1. So if you bring your power to the front, you're multiplying by 0, so the whole thing collapses down. So 3 rules. Power to front, take 1 off. X on its own disappears. Number on its own disappears. So let's see what that looks like. Y equals 2x3 minus 5x2, add 4. Power to front and multiply, 6x, take 1 off. Power to front and multiply, and take 1 off, so that 2 becomes a 1. And number on its own disappears. Now that's the basics, so let's see now how this builds up. Example 2. Before you differentiate anything, you must have it all written out in terms of y equals x's. So this is brackets, so times out your brackets first. X cubed plus x minus 2x squared minus 2. Then tidy it up. Oh, sorry, there was no tidying up to do there. Differentiate power to front, take 1 off. So 3x squared. X disappears, there's a 1 in front of it, so it becomes 1. Power to front minus 4, x to the 1, and 2 disappears. Now, in this question, you were asked, what is a gradient when x equals 2? So when x equals 2, you put your 2 into your dy by dx. So the gradient is 3 times 2 squared add 1, minus 4 times 2 to give you 5. And the third part of this question is asking you for the turning point. So you've got your gradient, dy by dx equals 0. So, sorry, I should explain. This is off the official SEA notes, so you might want to have these at the same time when you're working through this. Just getting up the SEA notes here so we can see them side by side at the same time as we work through it. So this is the official SEA notes, they're uploaded as well. So example 1, example 2. So that's what I'm trying to find. Find the gradient at the point when x is 2. Now find the coordinates of the turn of the points where the gradient is 0. So that's my gradient equals 0. So you've worked out dy by dx, put it equals 0. It's a quadratic. Either factorise it or use the formula. Whenever you get the x coordinates, there, don't forget to put it in to find the y. It's very easy just to give it x equals. So do it in turn. X equals a third. Put it into your y equation to get your y coordinate. And do the same for an x equals 1. Put it into your y equation to get your y coordinate. Now, example 3, again, just working from the official notes, differentiate that. Now, you'll notice I always start my work off with y equals. I would never just write the function down. So if you get into that habit, it would be great. So y equals 3x squared minus 4x 4 over 2x. You must split up any fractions and simplify. So that's 3x squared over 2x minus 4x 4 over 2x. That cancels to give you 3 over 2x minus 2x3. Now I'm ready to differentiate. The x disappears, leaving you 3 over 2. Power to front, so it's minus 6, and take 1 off, x2. Now, the next bit is tangents and normals. So he's going to say to you what a tangent is. A tangent skims along the outside of the curve, hitting it once at that point. You can see a tangent is a straight line, so it's the equation of a straight line. Y minus y1 equals mx minus x1. There's another tangent, hitting it there, and the gradient is, sorry, the equation is y minus y1 equals mx minus x1. Now, what's the normal? That's your tangent. The normal hits it at right angles. Okay, so the equation of a normal is y minus y1 equals minus 1 over m x minus x1. And that's just the same thing again. Okay, so tangent has got a gradient of m, normal has got a gradient of minus 1 over m. Now x1, y1 is the coordinate where the tangent or normal meets the curve. M is your gradient at that point. So you find y by dx and sub in your x. So we'll see it through a couple of examples here. It's quite a nice wee topic, this. Example 4. So I want the equation, again, it's just coming from there. So find the equation of a tangent to that curve with x coordinate 1. So equation of tangent, just writing out the question. There's my equation, y minus y1 equals mx minus x1. I'm at the point x equals 1, so you can sub your x equals 1 in. But I need my y coordinate to sub in. So when x is 1, this is me working out the y coordinate. So y is minus 1. So I'm putting it over here. So I've now got y plus 1 equals mx minus 1. I need to work out my m. And if you remember, your m is your gradient, so I need dy by dx. So differentiate your y, 6x squared minus 3. You know you're at the point x equals 1. So put it in. So 6 times 1 squared minus 3 equals 3. So that's your gradient. Goes there's 3. Just times out your brackets and tidy it up. Now you're going to see the equation of a normal now. So structure your work. Y minus y1 equals minus 1 over m, x minus x1. You were told the x coordinate 1, and you were told the y coordinate. So you didn't have to work out the y coordinate, which is handy. I need to work out my gradient though. So differentiate this, 4x minus 3. Put your x value in. So dy by dx equals 4 times 1 minus 3, giving you 1. So your gradient is 1. And just tidy that up. Now, the question there, if I just scroll it up here, show that the normal to the curve. So I found the normal to the curve at this point. And the question is, show it passes through the origin. So to show it passes through the origin, you just sub it in. So at the origin, 0, 0. So if you put 0 in y and 0 in x, 0 equals minus 0, so basically 0 equals 0, which is correct, so normal goes through the origin. And that is the last question, number 6. A curve has got this equation. Find the x-coordinates when the gradient is 6. So the gradient, remember, is divided by the x, put equal to 6. So differentiate this, 3x squared minus 2x, add 1 equals 6. It's quadratic, so everything on one side, so bring that over as a minus, tidy it up, factorize it, or use the formula. So you've got your x-coordinate. Again, the question says only find the x-coordinates. Find x-coordinates. Part 2. Find the x-coordinates of the point on the curve for which the gradient of the normal is minus a half. So a wee bit of thinking here. The gradient of the normal is minus 1 over m, and your total equals minus a half. So you can see, get rid of 2 minuses, m is 2. So basically what's m? M is dy by dx. So dy by dx equals 2. So you've got your dy by dx, or you can work it out again, 3x squared minus 2x, add 1 equals 2. Bring your 2 over, take it away, tidy it up, and factorise as normal. Now, just before we start the exercise, they want to sum up here a wee bit. Let's do it on the sheet. Gradient of a curve equals dy by dx, and sub in your x to find the gradient at a particular value or a particular point. The next thing, a turning point is when dy by dx equals 0. And then the other two things, equation of a tangent is y minus y1 equals mx minus x1, and the equation of a normal is y minus y1 is minus 1 over m x minus x1.